Hey guys, and welcome to the 11th day of Integral a Day. Got the selection tool on. And we've got a function today, which is mx, an integral, that once again utilizes, well actually I'm not going to spoil it. You guys pause the video and give this an attempt yourself, and then let me know how you go. So, yep, if you guys have a little bit of trouble just then trying to solve this, I'm going to have a shot at it now myself. So, this here, I've made this so it utilizes integration by parts. I did a question earlier today that had e to the x with x having a power on top of it as well. And it's interesting is when you do integration by parts and then you select this as dv, you actually get this like really weird complex integral. I don't know what they're called. I was researching it earlier, but pretty much stumbled across a few websites that gave some really good examples on how to solve this. So, as we've said in the past few videos, integration by parts is when we're integrating something. We can turn it into the form so that it looks like this. du. So let me just make sure I got that right. The textbook. Yep. So we can use this here, and pretty much what this is saying is we have to select a u term and a dv term, and then find the integral of dv to get v, and then find the derivative of u to get du, and then we can sub in all those values to actually integrate our function here. So we have to firstly select a u and a dv term. And as I tried earlier, I'm going to do it this way to show you guys. So I'm going to select this as dv, and this is u. Actually, well, that's wrong, because I'm actually not. What I'm going to do is this can be rewritten as x to the power of 3 times by x to the power of 2. I don't actually fully understand. I'm going to do more questions this afternoon on it. I don't know how putting x cubed here in front of e to the x cubed actually changes it. But we're going to select this as dv. Like, clearly the integral is going to be different. But just type into Symbolab just the integral of this, and I think you'd be quite surprised at what you get. But yeah, so splitting this first term up allows this to be a lot easier, simple. Now that we have our u term, so our u term is equal to x cubed, we can now do du, which is just the derivative of that, which is the power rule. Just, if you don't know how to do that, check out my first few videos, the channel. And then dv is x squared times our exponential here. So the integral of this function will give us v, which now turns it into a third of e to the x cubed. And now we can just simply sub in the values here. So I'm going to change color. It's a funny looking one. 2. That would do. So we have the integral of, well, our function here. Still the integral of this dot dx is equal to, so u sub un, get x cubed, multiply that by v. I'm not even going to write that. We don't need to. Now we're multiplying it. Now we integrate v. And then times that by du, which is 3x squared. And then integrating that with respect to x. So now this technically is our integral here of this. However, we can simplify this. Now, when doing this, I usually like to just bring the constants out the front. Just tidies it up a bit, really. And then we minus that by, well, 3 times 1/3 will actually just give us 1. So we're just actually left with e to the x cubed, x squared. So we can bring this constant out the front and multiply the constants together, and 3 times by 1/3 equals 1, and it's like timesing this here by 1, which can just really not write the 1. So now I think we're ready to integrate this again, which we integrated this earlier up here. So we already know what that integral is going to be. We just rewrite our integral from before. E to the x cubed plus c. So we've integrated it. It's an indefinite integral. So we add our term of our constant of integration. And I think this is as far as we can actually do this now. So let's check this on Symbolab. So Nisha integration calculator. And let's see what Symbolab says. So we have to the power of 5, so e to x cubed. I think I wrote that in. Yeah. I wonder if Symbolab is going to write this weirdly now. Okay. Oh, so they brought the 1/3 out the front, and then they got, oh, nice, okay. X cubed. I wonder where they got that 5 from. Let's write it as we wrote it earlier and see if that changes how they represent it. Yeah, it does. So I'm just alt-tabbing between them. Yeah, sweet. So we actually got the same answer as them. What they did is they brought the 1/3 out the front. We have E cubed x cubed minus E x u. Let's see. I'm going to go back quickly. Yep, so this is what they got. And I just brought the 1/3 out as well. So both of these are like right, it's just this is further simplified. Let us know if you managed to actually simplify this even further or got a different answer or actually have a better way of doing this. I'd be really interested to hear on how you guys do it differently. And yeah, hope you guys have a lovely day, and I'll catch you all back here for the 12th day.